This is our group project presentation for group 4, which is in lab 4, cooling tower. Myself, Lorani Sulokang, and my other friends is Nurul Ain binti Muhammad, Farzana Balkis binti Muhammad Zulkifli, Chia Chunfong, and Sarvin Vijayan.
So next I'll go through the introduction. So as a cooling tower is a device for removing heat from the environment. It does so by lowering the temperature of the water stream. Cooling tower can either use water dissipation to cool the working liquid or to remove the heat from the operation. And due to the closed-circuit dry cooling tower, the working liquid must be completely cooled by the A in order to get it close to the dry knot A temperature. And common use include cooling the circulating water used in petrochemical and other synthetic factories, thermal power plant, and HVAC system for the cooling building. The classification is based on the type of the air intake into the tower. And the two main types of the cooling towers are common draft and also the forced draft cooling tower. And a closed flow cooling tower is employed at the UTHM biodiesel facility to cool the utilities line and provide cooling to the plant. And the wind current is direct away from the water stream in a closed flow cooling tower. To meet the feed material, the wind stream enter at least one of the cooling tower vertical face. In contrast to the A, water flow by gravity through the feed, and the air flow through the feed and over the water stream in this manner, entering an open volume. And finally, the air is refreshed uh, from a fan. A closed flow tower highest point is adjacent to the dispersion or high temperature water flow, which is made up of a deep disc with apertures in its base, so water is uniformly distributed over the feed material by gravity through the spoons. And next is about the objective. First, we have to identify the type of cooling tower in biodiesel pilot plant UTHM and in the market. Second, we have to analyze the energy cost of cooling tower to operate for biodiesel plant in 8 hours daytime. So the next is about the theory. Commonly, there are two types of cooling tower, which is the mechanical and also the natural draft. It depends on the size or the capacity of the power station. So this cooling tower can be utilized. And the first one show that the natural draft. The tower with natural draft is cascade down the inside of the tower. Fans are not used in natural draft towers to provide airflow, and electric pump inside the tower are used to pump water up the interior. In order to break up the flow and increase the surface area of contact between the air and the water for effective cooling, the water typically encounter metal plate and also known as baffler. And for the second is the mechanical draft. Large fan inside forced draft cooling tower push air through the smaller tower, and the image display four tower in their reciprocal bosses and are common in industry setting for cooling water. These are the same cooling towers. They are used as a part of the air conditioning system on office building.
Hello, my name is Lorani Selokang and I'm going to present about the procedure. The first one is safety precaution. Workplace safety is very important for each student in the biodiesel plant because all the students desire to work in a safe and protected atmosphere. Health and safety are the key factor for all industries to promote the wellness of both employees and employers. It is the duty and moral responsibility of the student to look after themselves in the plant areas. The safety measure that can be reduce accident in plant area would be, the first one is wear appropriate clothing while conducting the cooling tower. The second one is wear personal protective equipment, which is PPE, while in the plant area. The third one is follow the instruction from the instructor in the lab sheet rule. The fourth one is do not play in the plant area, and the last one is do not bring a flammable and explosive items in the plant. As for the startup procedure, there is a step before running the cooling tower in the plant that must be done to make sure the cooling tower run without a problem. Below other steps are needed to run the cooling tower. The first one is to track and check the condition of the piping system according to the PNID. The second one is to make sure the valve along the piping system is open. The third one is switch on the suction pump motor, discharge pump motor, and cooling tower fan at the electric box. Pour 0.5 kg of Cl653 chemicals into the water basin to avoid microbiological build-up. As for the shutdown procedure, after finishing all the process in the plant, the cooling tower must be turned off. But there is a step to follow properly to make sure the cooling tower to fully shut down. Below are the steps that are needed to shut down the cooling tower. The first one is to track and check the piping system condition. The second one is to make sure the valve along the piping system is already closed. And last one, switch off the suction pump motor, discharge pump motor, and cooling tower fan at the electrical box.
Hi, I am Farzana Balkis, unit number CN190119. So now I'm going to present about the results of the experiment. So firstly, we're going to determine the electrical motor power for cooling tower, which consists of 3 items, which is suction pump, discharge motor, and also fan. So from that, we determine the power of each item and then the usage for 8-hour watt. Next, we're going to find the base on tariff B, low voltage commercial tariff from TNB. So from the tariff category, we have the first 1 until 200 kilowatt hour per month is 43 ringgit 5 cent per kilowatt hour, and then for the next is 50.9 cent per kilowatt hour. So the total RM for the power consumption is 1964 ringgit Malaysia. So lastly, we're going to determine the cooling tower efficiency by using the illustrated formula. So the parameter given is hot water temperature 47 degrees C and cold water temperature 32.5 degrees C, and wet bulb temperature is 26.7 degrees C. So from the formula that have been stated, we got the cooling tower efficiency of 71.42%.
The observation we observe in the cooling tower in our biodiesel plant. So the heat transfer phenomena in the cooling tower water. The phenomena of wet cooling tower is measured in terms of its approach. So how close temperature of cooling water comes to the wet bulb temperature of the ambient air when water is cooled through the desired range. The fan motor, suction pump, and discharge motor are all electrical components used in a cooling tower process. So these components provide the electricity for cooling tower to functioning. So each component's power was determined during in 8 hours period. So the fan motor use 3700 watt every hour for a total of 29,600 watt when multiplied by 8 hours. So the suction pump consumes 1500 watt of electricity while drawing 12,000 watt. So the discharge motor utilized 11,000 watt of electricity in every hour, which should total 88,000 watt of power when operated for 8 hours. So when the figures are added together, so the total power production per 8 hours is 12
129,600 watt. So the monthly consumption is predicted is to be 3,888 kilowatt. So the entire expenses was the entire using tariff. The total monthly cost is Rm 1964.19 cent for cooling water. So in conclusion, the usage for 8 hours of electrical motor power for cooling tower and tariff from PNB as recorded in the biodiesel lithium plant. So the energy audit is an effective way to identify the energy used in energy loss in the system for the future improvement. So several saving possibilities as non-cost technique for energy conservation opportunity. So cooling towers provide a cost-effective and energy efficient operation for uh, system in the need of cooling. So a cooling tower works by taking unwanted heat from the water and releasing it into the atmosphere. So it brings cool and warm water into contact to efficiently cool the water and reject the heat through evaporation. So cooling towers are among the most effective cooling water system available, making it an important meter efficiency. Thank you.
We move to discussion point, and from table 1, it shows the item quantity power which is in unit of watt and power usage for 8 hour for the electrical appliance at the cooling tower usage and biodiesel pilot plant. Firstly, the highest usage is the discharge motor from Teco brand, which is 88,000 watt hour that has power of 11,000 watt and only have one unit there. The second highest usage power is the fan from Teco brand, which is 29,600 watt hour that has power of 3,700 watt. Thus, the lowest usage power is the suction pump from Ibarra brand that only contribute to 12,000 watt hour and has 1,500 of power itself. The total usage for 8 hours is 129.6 kilowatt hour. Next, we go to the table 2 that focus more on the tariff use for calculating the usage power cost, and the tariff use for this cooling tower is the tariff B. This is because the pilot plant is characterized as low voltage conversion. Moreover, in tariff B for the first 200 kilowatt hour, the rate is 43.50 cent, and the rate for the next kilowatt hour is 50.9 cent. To calculate the cost usage, first we must calculate the usage power for 1 month, and the total consumption for 1 month is 3,888 kilowatt hour per month. Based on that, the first 200 kilowatt hour must multiply with 43.5 cent and resulting to Rm 87 ringgit. And after that, the next 3688 kilowatt hour must multiply by 50.9 cent and resulting to Rm 1877.20. And the final usage cost for 1 month is 1964.20. Last but not least is the cooling tower efficiency part. Firstly, we must know the formula to calculate the cooling tower efficiency, and the formula is shown in the result part. And from the formula, we must get the data for hot water temperature, cold water temperature, and wet bulb temperature. The wet bulb is the lowest temperature at which air can be cooled through the constant pressure water evaporation. Based on data, we get the hot temperature is 47 degrees Celsius, the cold water temperature is 32.5 degrees Celsius, and the wet bulb temperature is 26.7 degrees Celsius. And after we apply all the data into the formula, we get the cooling tower efficiency for the UTHM biodiesel pilot plant is equal to 71.42%. And based on the practice, this value is in the range of normal efficiency of the cooling tower, which is from 70% until 75%. Thus indicated this cooling tower is still in good condition and can work efficiently. Lastly, the reference, and for this practical, we have 5 reference.